All right, let's start simple. What gap were you trying to close with this benchmark?
I think that real-world audio is very messy, and a lot of eval data sets used don't reflect the real world. They are either based on audiobooks or on very clean recordings. We try to come up with a dataset version that has a lot of variability in all these things.
What breaks in reality that looks fine in a benchmark?
Most ASR test sets are based on some sort of pre-collection. Yeah, and that means, for example, large collections of audiobooks. And that is obviously not what you see in production. In production, you see different loudness, different speaking styles, different positioning to the microphone, different rooms, different surroundings. Yeah, the real world has a lot of variability when it comes to how voice is captured.
Can you walk me through how you built the data behind it? Was it recorded in real environments, as simulated, or a mix?
We simulated the dataset by positioning loudspeakers or artificial mouths and these devices into different rooms and then place different devices in front of it at different distances. Additionally, made sure that we also have some interfering noises from the background, either by artificially playing them or by opening the window or recording in noisy places. And this makes it much easier to create datasets of several hours without a person actually having to speak and get a group of people to speak there. And this also means we have the clean data, which we can combine this, so in this dataset even has ground truth, which is very cool.
Okay, so when we look at the comparison, what exactly are we comparing here?
Right, so raw audio means you'd use the noisy audio without any processing. So that would be like you would have it in the real world, right? So you don't put any processing on the audio. Crisp is kind of default processing for speech enhancement. Quail is a real-time, very lightweight model, is optimized for speech-to-text models. A deletion is you put either the raw data, like the noisy recordings, or the processed data, audio files, through a speech-to-text model, and we use different providers. Then you get a transcript predicted by the model, and you compare the actual correct transcript and the transcript generated by the model. A substitution means a word was changed. Deletion means a word is missing, and an insertion is there was a word added. And then you combine these to the word error rate by dividing it by the total number of words in the correct transcript.
And you mentioned something like a 10 to 25% relative word error rate reduction. What does that actually mean for users?
I think there are some mistakes that are not critical because usually in a voice agent case or even for transcription you have an LLM to correct the output. But if it comes to the point where it really just changes facts, that can make a big difference. You know, if you're missing a yes or no or not in a sentence, it can completely change the meaning. If you're missing date or number, it changes the meaning completely. Yeah, it can either be that the turn taking is really worse and that means conversation flow is worse. That's the one thing. And the other thing is that the downstream model can just get things wrong factually. Maybe 24 and 4, right? And if it's transcribed 4 because the 20 was obfuscated by noise, it's just a wrong fact.
If someone only remembers one takeaway from the results, what would you want it to be?
STT-optimized speech enhancement actually works, which is very interesting, at least for most APIs that we tested here. Using perceptual speech enhancement doesn't work. Real-world messy data, you can improve the word error rates with specialized pre-processing. But what you shouldn't do is just put a model optimized for perceptual quality for human quality. You shouldn't use that as a pre-processing, but with specialized models you can make most of the commercial APIs better, even with a real-time lightweight model like Quail.
Is this true for all use cases or mainly for voice agents?
It's worth trying it out for your use case. If you just want the audio to sound nice and you present it to a human, then obviously you want to use a perceptual speech enhancement model, but for voice agents, for transcription, and all these use cases, if you want to use an AI model downstream to transcribe your audio, don't use a speech enhancement model that is optimized for perceptual quality, but use one that is optimized for speech-to-text enhancement.